So, for this third video now on differentials, once you're straight that we can use f of x plus delta x approximately equals f of x plus f prime of x dx, where this part is the approximate error. And we're, sure that we need an f, in which case we're going to have f prime, we need an x, and we need a delta x. So for instance now, if you need to approximate the square root of 8.9, well, you need an f, you're talking about the square root of x. You need an x. Well, for the x, you want to choose an x value close to 8.9. So that the function square root of x is easy. So of course you're going to choose x equals 9. For the delta x, you want to say to yourself, how far did we move to go from x equals 9 to x equals 8.9? And that answer is negative 0.1. So now you've got your f, in which case you've got your f prime, you've got your x, you've got your delta x, just like we did on the previous page and in the last couple videos essentially. Now you can say everything you need to say about this. You could approximate the square root of 9 as f of x plus delta x, right? You could also find the approximate error, etc. What do you do if you need to approximate e to the 1/13th? You need an f. Well, your f of x is going to be e to the x. So now you've got your f prime. You need an x. You want to choose an x value close to 1/13th so that the function e to the x is easy. Well, that x value is x equals 0 because e to the 0 is easy. Don't choose e to the 1 because 1/13th is nowhere near 1. You want to choose an x value that's, close to the 1/13th. Now you need your delta x. Well, your delta x is how far did you move from x equals 0 to x equals a 13th. And so now you got your delta x, and it's positive a 13th. So now you got your f, you got your x, you got your delta x. You use this like a formula. What happens now if you need to approximate tan inverse of 0.997? So your f of x is going to be tan inverse of x. Now for your x, you need to choose some x value close to 0.997 so that the tan inverse of that x is easy. Well, that's going to be x equals 1 because the tan inverse of 1 is easy. For your delta x, you want to say how far did I move from x equals 1 to x equals 0.997, and this is going to be negative 0.003. So now you got your f, your x, your delta x. You use this like a formula like we did in the last video with the y equals x cubed function. What if you need to approximate 1.04 times the ln of 1.04. Well, your f of x is x ln of x. Now for your x, you need to choose some x value close to 1.04 so that the ln of x is easy. That x value is going to be x equals 1 because, 1 ln of 1 is easy. So for your delta x, how far did you move from the x equals 1 to the x equals 1.04? And that's a forward movement of 0.04. So now you've got your f, you've got your x, you've got your delta x. You use this like a formula. Now, the one that can get a little bit dicey is when you have to approximate the sine of 30.3 degrees. Well, the thing is you can't work in degrees. You always have to work these things in radians. So you're really talking about 30.3 degrees times pi over 180 to change that into radians. Well, this is like 30 plus 0.3 times pi over 180. So this is like 30 pi over 180 plus 0.3 pi over 180. Well, see the 30 over 180, this is pi over 6, and I'm going in on that because taking the sine of pi over 6 is easy. See how you're taking the sine of something close to 30 degrees? That's the pi over 6, but we're basically changing this into radians and dealing with some of this little cumbersome little, changing here to go 30 plus 0.3 is to go 30 plus 0.3 pi over 180. You could just leave it like this, but you can also realize that this is like, well, if I multiplied this by 100 over 100 to make this 30 over 180, then the 30 over 180 would be another pi over 6. And when I multiplied it by 100 over 100 to turn this into a 30, that brought a 100 down there. In other words, this is a 0.01. This is 0.01 pi over 6s. I'll let you sort out the arithmetic on that. You could have just left it just like this, but really all I'm saying is, see the point, this is like when I take 0.3 pi over 180, if I wanted to go over 2 decimal places there, then I multiply by 100, so I'll do 100 over 100, so I'm not changing the value of this thing. Now this is 30 pi over 180. There's the 30, there's the pi, and I've got this 1/100th in there. In other words, it's 0.01 pi over 6, is what I'm saying. So once you've got this sorted out, then, you realize you're taking the sine of pi over 6 plus 0.01 pi over 6. And so you need an f of x. You've got your x, and you've got your delta x. And you use this like a formula.